Okay.
Alright. Hello. Yesterday we had established this formula. I failed to tape it. I left my camera at home. But this is the result. So if you would start with that, you will be fine. So here is the period formula, and that will be in seconds. It involves pi to pi square root of the mass over the spring constant, K. So we did our first problem, and we plugged in the numbers K. We had to we didn't have to change because it is mass. We did not have to change. We had to change it to kilograms. That's what I remember. So we had to use 0.345, and when we plugged that all in, we got the period was 0.62 seconds. And I'm sure you can confirm that. All right. So we're all on the same spot now. So let's go ahead and sketch this problem where you're working on, you said day 5? I'm sorry, I keep forgetting what day it is. Yeah, day 5. Day 5 notes. So go ahead and sketch this new one. This is brand new. You have a spring that's just hanging without any mass, and then when you put the mass on, it brings it down this amount, and then someone is going to pull it down an additional 35 and release it. So it's going to be released from here. So this is hold and then release. At that time, at that point, I want to know the period. The thing is going to bounce up and down and up and down. So you have the tools to figure that out. And you start. Sketch out the problem so you can see it later.
You did paper yesterday? It wasn't even good. It wasn't good yesterday, but like, she's like, she didn't think.
We're going to use the same formula, so you'll see quickly what part is missing from the work. Over here it was pretty much plug and chug. What's missing, MD, when we try to immediately fit this formula into this work?
T.
Pardon? Well,
T?
yeah, well, T is what we're looking for, but inside the formula.
Oh, K.
K. So, but you have been trained to find K, so take out your K. This will help you remember. Take out your K training and figure out what K is before you find period. So we start with your formula. This is what we're looking for. We know mass, but we do not know K. So you're going to have to go over here and find K before you can complete the problem. Can I peek at your K?
Getting worse.
Raise your hand when you got the K part so I can peek at it. So MD, or MK, sorry. MK, we had a spring that's just hanging around, and then we put a mass on it. It brings it down to this many centimeters. And then we're going to pull it from there down 35 more centimeters, and we're going to release it, and we're looking for the period. So we're using our period equation, big T.
How do you find the acceleration for it? Because
Acceleration?
force equals mass times acceleration.
Yeah, I was gonna say, when you're writing K, you're
This is what we use for K.
Force. Well, force would be ma.
So why do we need,
But-
force is
You
just
don't have
weight.
K.
Oh, it's just the weight.
Force is just the weight.
Oh.
So that's weight, and we're given mass, but we can quickly get to weight. I hardly mention that anymore. I did put it up there. Anyone have a K I can peek at?
I think chickens would be a really good idea. And my friend has chickens, but I just don't know how to get them here to school.
I got one, but I don't think it's right.
You got a K, but you don't like it?
I don't like. Wait, no.
I just want to see your K first.
That's what. I don't.
Let me see. What'd you get for the force? Oh, you didn't.
300.
I didn't write it out. I just did it.
It's the mass times 9.8.
Yeah, that's right. Divided by. Okay. So what? That number. Maybe I did it.
No, I don't think. But I don't think I would get such a big answer. I think I just converted it wrong. You have to convert it to meters, which would
This
be.
is the part. Oh yeah, meters.
Which I
It's pretty
did.
big. This is where you find your K. Are you looking in the right
Oh,
spot
you
for
don't
K?
do. You don't add it to the other one.
Right,
Okay.
Because remember, K is how strong the spring is.
Okay.
So if you're having someone pull it, that's not going to be right. So you're going to have to use the part of the problem that shows how strong the spring is, which is represented by just hanging the mass on it, not
Okay.
pulling it down further.
Okay, and then I got another answer.
All right, let me see that one.
I got it as negative because it's supposed to do just negative.
Well, we're kind of like you could say X is negative. You could say that that
Okay.
went down, and then
So double confused for everybody.
all right. And I just used 2 sig figs at that point.
Okay.
So now he's fixing the serious and everything.
All right, I found a good K. Do you have a good K for me, Zach?
Wait, Miss Powell. Wait, or F, I guess.
Yeah.
When you're plugging in the F equals
Uh-oh,
KX,
you went part of my
the X that
calculator.
you
You
use is
burned it.
59.1.
Yeah, but you have to
Really?
convert. Yeah, you have to convert it.
But you don't use like the 35.
No, you don't use
No,
that.
it didn't tell me that. So
You use 35, you use 35.
25, rearrange the batteries.
All right. What were you saying, Emily?
I was asking a question.
All right, did you get a K yet? How about you, Ryan?
I'm thinking about it, and I don't think I got the right.
Oh, you got one on your calculator. What happened to your calculator?
Cleared it.
Oh, you cleared it.
Yeah, I
Okay.
got the wrong answer.
got
All right.
answer.
The
Wow,
final.
you're so cool. I wish I was you.
The period is.
I'm gonna feel
Didn't I finish it? Okay, I guess I. Oh yeah, I did. Ta-da.
Yeah, that's okay.
All right.
Do you want me to
Alright.
stop recording this or just keep on going?
I'll show how to do this one,
Okay.
and then we'll stop.
Just have a momentary
All right,
lapse.
in video land, oh, you got an answer? Well, I'm going to show you how to do that, and then we're going to be working on problems like that. So just hang tight. I'll show you how
Hang
to do
tight.
this
I'll just keep
one.
on zooming in and out for your amusement. Just kidding. That'll probably give you a
All
headache.
right, that is. What number did you use? 30. All right, so you want to make sure that's in. Let's say 4.5. That must have been the weight. Yeah, it's like 5.9. And you got 58.4, and I did it.
That's what I said what I did. And they get mad 'cause
I don't know what. 34.5 is the mass times 9.
You should, I'm simply just gonna fix that. It's against the law, so.
Alright, did you get a K?
Okay, do I multiply this?
Yeah, after you have to get 5K
Yeah.
first, so you gotta use this
Negative.
over on the side, and then we'll come back.
No,
to
you can make
What is X?
X
I know
negative.
X.
Where's X?
Wait, negative K.
X is how far it was pulled down by the mass.
Oh, which is 59.1?
Yes, but we're gonna work in meters.
Oh, so it'd be.
Slow down. Let's get one girl's at stake.
Yeah, I can't
We're
really
gonna move it over twice.
Oh, one by now one, alright.
Alright.
seasons
Alright.
of a show in 2 days.
Alright,
So it F.
let me
was
jump
four.
in and show you how to do this. Inside this red box, I can find K with F equals minus KX. We were pretty good at doing that before the break, so a little rusty right now. Force is provided by the weight, so we have 34.5 times 9.8. The mass is changed to weight by multiplying by 9.8. Weight equals mg. Negative K. X is how far did it come down when I hung the mass on it. It's 0.5, we'll say it went down negatively, negative 0.591. So when you solve that for K, see if you do not get something with sig figs around 580. So now it is a plug and chug situation. You put the K into your period. We're trying to find the period. Once we pull this down, how long will it take it to go up and back down? So the period is 2 pi. Mass, remember, is in kilograms. The mass is it's 34.5. And the K, we just calculated as 580. So with all that, do you get something about 1.5 seconds? So